Hi guys, welcome back to exercise part of lecture number 7. So we are going to develop a banker's algorithm today. Now as I said in the theoretical part as well, you're free to use any programming language you want to use to program this algorithm. I'm going to use C language just for consistency since we are using this language for since the beginning of this course, so I'm going to use that. Alright. So these are few of the requirements of this Banker's algorithm. So it says that work for a set of processes and resources. So we are going to have some processes 3, 5, 6, and we are going to have some resources, and we are going to have the instances of those resources. Then if possible use struct or classes, but you are free to, so it can be solved anyway. I'm gonna use struct in this exercise, but you're free to use classes. You want to do it using multi-dimensional array, you are free to use that. As long as the requirements of Banker algorithm are fulfilled, you're free to use it any way you like. And the other requirement is program should display the following attributes. So process should have an ID, it should display the number of allocated resources for each instance of the resource, maximum resources required, number of needed resources, and it should display finally if the process is in safe state or unsafe state. So we have to display the sequence of that state. So we already discussed about that. I think I have an example where it shows the sequence. So if you remember, we did this exercise and this is the sequence which is shown. So we want to make sure that our program outputs something like this. So if it has a safe sequence, it should display the sequence as well for us. So let's get started. I have my Ubuntu up and running. So let's work on saving this first of all. So I'm gonna use temp, and I'm gonna call it banker.c. I think I already have it. Banker.c. Let's see. No, I don't have it. Okay, so let's see what we have to do in this program. So what I'm gonna do is I'm gonna start with including some libraries. So as always, stdio.h, and I'm gonna include stdlib as well. So stdlib.h as well. Let's start with our method, main method, return 0. Okay, so we can hard code the values, I think. So work for the set of processes and resources, and you can hard code them. So I'm going to take few resources and I'm going to take some processes also. So what I will do is I will define it at the beginning. So I will say number of processes. You can put 5 in the loops, since I'm going to use this to display and running through loops and so on. So I'm going to define it over here, since I'm going to run multiple loops. So I don't want to just have 5 and 3 running over there, because if you change number of processes and number of resources, you have to always change them inside the loops and so on. So I'm going to change it over here and it will change everywhere in the program. So that's why I'm using this directive. So, and I will use the same thing, number of resources, and I'm going to call it, let's use maybe keep it simple 3. So this is this. So I have defined them. I have now 5 resources, 5 processes and 3 resources. I'll define them in a while. What I'm going to do is I'm going to use structs to define my processes, and you can use classes or multi-dimensional array, but I'll use struct. This makes more sense to me, and let's do that. So let's create a struct. I'm going to call it a process, since it's going to contain multiple things inside, and it always ends with a semicolon, we know that. So it will have a, let's see, it will have a process ID. So I will call it PID, for example, and it will be integer type. Then it will have number of allocated resources. Okay, so I will call it let me call it allocation, int allocation, and allocated resources are going to be array, because there are going to be multiple instances of each resource, right? So if I have 3 of them, then I might end up having 9 of them, right? So because I have 3 resources and there can be multiple instances of this. So I'm going to have an array. For all the resources, I'm going to have an array, to be honest. So number of maximum resources required. So how many maximum resources, this is what I'm talking about. So it has something, it needs maximum of these and so on. So this is what I'm creating right now. So int maximum, let's call this 10 integer array. And how many does it need? We can calculate this as well, but I'm gonna hard code it just to make it simple. So how many resources does a process need to complete this execution? I'm gonna hard code this value, right? So but you can calculate, if you remember I showed you in safety algorithm as well, you can calculate that using that calculation. Where is it? Yeah, it was Banker's algorithm. So this one, right? So you can calculate that using this formula as well, but I'm gonna directly do that just for the simplicity purposes. So these are the 4 things, I guess. So let's go back to exercise. So PID, number of allocated, maximum needed. Yeah, so these are the 4 things I'm looking for, right? So I've created a process which contains all these things inside. Okay, now what I have to do is I have to define my processes. So since I need to have 5 of them, let me first of all do this like this. Since I'm gonna create an array of processes, right? So this is an array of integers. I'm gonna create an array of processes. So each element of my array will be a process that contains inside these things, right? I hope you guys know this because it's something very similar in classes, and structs are very similar to that. So I'm gonna create that, and I'm gonna hard code the values. As I said earlier, I'm gonna hard code these values, but you can take it from the user as well. So in C you normally do this. So PID, I'm gonna call it PID be 0. So PID of the first process is 0. This is what I'm putting. And I'm gonna, next is int allocation. So I have 3 resources and they have multiple instances, right? So I'm gonna say the first one is 0. For process 1, it's it has these many resources for these 3 resources, right? So it has none of the first resource, and it has, I'm just gonna put random values, and it has 1 of the second resource and 0 of the third resource. So something like that. And yeah, I'm doing it right. Yeah, okay. So that's this. Maximum is how much it needs for each of these 3 resources to complete, right? So I'm gonna again randomly put some values, but you can change these values and check the sequence. The sequence will definitely change with these values, as we have discussed. And since I have put this value, I'll just have to calculate this, how much it needs. So how much does it need? So this is the maximum it requires, and this is the one it currently has. So it needs 7 to complete, because 7 minus 0 is the need. So it needs 7. Then it has 5 minus 1 is 4. Then 3 minus 0 is 3, right? So this is the process 1. All right, I'm gonna copy paste this for other processes. Oops. Okay, so I have 5 of them. This is what I have. Yeah, so process 1, 2, 3 and 4. So I have 5 processes. Okay, so I'm gonna again randomly put these values. 2, 0 for example, maybe let's keep it 0. Let's make it 3. Let's make it 2, and make it 2 as well. And we just subtract this. I don't want to put minimum negative value, so I have to just make sure. So 3 minus 2 is 1. 2 minus 0 is 2, and 2 minus 0 is 2. Yeah, okay. So process 2, I'm gonna just do something very similar. Let's make it 3 maybe. Let's make it 0. Let's make it, I don't know, 2 maybe. And how many it needs? Maybe put some large values, maybe 9. Make it 0, right? And make it 2. Yeah. And we just subtract this. So this is going to be 6. This is going to be 0 minus 0 is 0. 2 minus 2 is 0. Okay, that's fine. Let's do this. Okay, so I hope you guys understand this need array is just how many it needs, just to quickly show you if you don't understand. So over here, this is allocation and this is maximum in our array. What will be the need? Need in this case is 2 because it needs 2 to complete, and I'm just hard coding that value. Okay, so just to keep it simple, I'm just hard coding these values. So I was done up till here, right? So yeah, I was done up till here. So 3, maybe 2, keep it 1, make it 1, and let's make it 2, maybe 2, maybe 2. And how many it needs? It needs 2 minus 2 is 0, 2 minus 1 is 1, and 2 minus 1 is 1. Okay, last one, again some random values. Let's put 0 over here, maybe 2, and how much it needs? Maybe 4. Let's keep it 3, and let's keep it 3 as well. And 4 minus 0 is 4, 3 minus 0 is 3, and 3 minus 2 is 1. So we are done with our processes. So I have created the processes and they are complete. Alright, so we have created our processes, 5 processes. We might need to change them and I will tell you why, but for now let's do it this way. Okay, so this is this, and next thing is we have to know how many available resources we have. If you remember, we need to know these, right? We need to know these, only then we can work. So I'm going to create an array of, let's call it maybe available, and for how many resources we have to find these availables? 3. We have 3 resources, right? 3 different resources. So for example, one is a printer, one is a scanner, one is a keyboard, and these are 0 printer scanners, 1 printer, 0 keyboards, stuff like this. Okay, I hope you guys understand. This is exactly what we did in the theoretical part. And how many available for each? So I'm going to create an array just like this, so that each one contains the instance of available resources. So I'm going to call it number of resources. So since it's 3, I can directly input 3 over here, but since I created this, I'm going to use this. Okay, and let's assume some random values. We have some random available resources. So obviously you are going to, when you are going to change these values, it's going to have an effect on the sequence, on your save sequence, right? You're going to change any one of these, you're going to have save sequence problem. I mean, it's not a problem, it's going to change, right? So this is this, and yeah, we now have this one also. And what I'm going to do is I'm going to put my sequence. So this is P0, P1, P2, P3, P4. So it's going to show us maybe something like P1 dash P2 dash P5 P4 dash something like. So it will show us the sequence, something like that. So I want to save that sequence maybe in an array as well, right? So this is what I'm going to do. I'm going to create a sequence array, and just to be safe side, let's make it 10. So I'm going to save that sequence inside this array, and the array contains these processes, right? That's this thing. That's pretty much it. And let's work on displaying this first of all, so that it's clear what we are actually doing. So I'm going to display something. So let's display our, okay, let's start with this. So I'm going to say how many are available for us. Available resources, at least we keep an eye on that, are something like this. So will be, I'm going to call it R0. So it's going to be something like this. Then maybe you can put a tab, or you can decorate it whatever way you like, but I'm going to just put it like this for now. And R2 is going to be mod of D, and I'm going to put a new line over here, and let's just give it a value. So resource 1, how much is resource 0 for me? It's 3. Resource 1, 3, and 2. So I'm going to just use these values. So available resource 0, I'm going to copy it and do this. This is 1 and this is 2. I'm gonna see the output first. So let's see what do we have right now. Okay, so cd document, cd temp, and we have to compile this. So banker dot c dot o. Banker is capital or with small letters, I don't know. Yeah, okay, so it compiled well. Let's run this, see what we have. So yeah, so this is what we have displayed right now. So yeah, R0 is 3, R1 is 3. Yeah, perfect. This is what we wanted to display. What I want to do now is I want to display all these things as well, just to see how many each thing has. And it would require me to run a loop because these are arrays inside, right? So let's do that. At least we see something as an output. It's always encouraging to see an output. So I'm gonna do this. So process, because of, you can call it process ID or process. I'm gonna keep it process. And then we have, what is next? Allocation, right? Allocation, yeah. So allocation, put a tab here. Then next is maximum, then tab, and then what is next? Need. You can name it anything you like, and I'm gonna put a new line over here. So this is this, and what I want to do is I want to display these values under each of these. So these are headers. So let me quickly run this to see if we are doing right or not. Right, so this is what we have. For each process we need to see the allocation, the maximum, the need, and so on, right? So we need to put for each process all of these things. So I have to run a loop, right? For a loop, let's do that. So int I is equal to 0, I is less than, so we have to run it for each process. So I will do number of processes. So within each process we have these three things. So for each process we have these things. So this is what I have to do, and I++. So for each process I have to display how many resources it has, how many it needs, and how many are maximum for its execution. So I have to run another loop for resources now. So for each resource, so for each of these I have to run it, right? So let's do that. Int maybe j is equal to 0, j is less than number of resources. So number of resources j++. And we just do a printf now. Let me use this printf, looks reasonable to me. So let's see, we just need to replace this by process ID. So no need to put a new line again, it will be too much new lines. So I'm gonna say p, and since I'm going to get p of I, so it will give me p of 0. So I'm gonna say p of I, p of I, which will be p of 0, since in the first header I just need the process name or process ID, and then do this. Then allocation, for allocation I have to do again, I just have to replace this maybe by, yeah, so I need to have the name. So let me do this, and for maximum also I'll just put the numbers. Why I'm doing this, these are numbers inside, right? For each array these are numbers, so I'm just putting numbers. So I'm gonna do this, I'm gonna do this, this is this, and we just need to put their values. So so this is p of not p of, it's proc I of PID. So for the first process I am in this line, right? So for p of so proc of I, so for proc of I am in the first row, so I will say proc of I, which is the first one, since these are 5 processes and each one of them is a type process. So this is an array of processes, so each one of this contains each line. So proc of I, which is proc of I of 0 dot, what is the name, PID dot PID, so dot PID, this one, that's good. And so I came here, inside this I have this one, which is going to be j of 0, so j of 0, so I'll just display j maybe here, and then proc of no, sorry, yeah, so j of 0 will be this one, right, because this is what I'm going through. Inside inside each process, these are my j's, right? So inside this is going to be j, and what I need now is for allocation, I'll do the same thing for allocation, proc of I dot allocation, right? So this is what I'm doing, proc of I of allocation, which is this part. Inside this I want to get the j of allocation, so allocation of j, so allocation of j, right, which is this part, right? Okay, and I do, so once I've gotten there, I just display the value of j, right? And for maximum I do the same thing, proc of I dot maximum, I do a j, and I just display the value of that j, and then I do the same thing for need as well, proc of I yeah, for need of j. And let's see, no, I don't need these, I need 4, 1, 2, 3 and 4, so forget about j's for now. So let me remove these, and that's pretty much it. Reduce the size a little bit so that you guys can see. Yeah, so let me save and run this and see what we have. Oh wow, that's one fine. Okay, so yeah, it should be aligned properly, maybe double taps I need. So P of 0 is the first process, so it has allocation of 0, that's good. It has P of 0 allocation of 1, which is good. Let me align it properly so that we can properly see what's going on. Maybe double taps here will help us further understand this. Double tap, double tap, double tap. Let's see now how it looks like. And what I'm gonna do is I'm gonna put a line underneath each process. So after this for loop, maybe I'll just put a line underneath it. Let me just remove this one, and maybe something like this, just put some dashes so that we know after each processes what we have. Oops, I missed something. Oops, missed a slash here. Okay, let's do it again. Okay, now we have something much more clearer. So P0 allocation for first process is 0, that's good. For P0 the maximum is 7, which is this, and need is 7, that's very good. So, and it's doing P0 and then it's going through the next one, which is 1, then 5 is maximum, then 4 is the need, and then 0 and so on. Excellent. So this is exactly what we were looking for, right? Maybe we need to put some more dashes over here to extend this. One more thing, that's what I wanted to do over here, just put a J so that at least we know which resource is this. So right now we don't know which resource is this, right? Like here, so this is resource 0, this is resource 1, and this is resource 2. At least we should know from each resource what these resources are. That's what I wanted to actually do. So let me do now. So after process 0, I can put R0 is equal to 0. So over here maybe I can put something like this. So I'm gonna do something like this, mod d, and it will show me r of 0, and then it will show me that, and I'm gonna put a j here. Let me see if it works like this or not. Yeah, perfect. So r0 is 0, which is this one, r1 is 1, r2 is 0, and for all of them. And what I can do is I can do the same thing for these also. So let me do it, since I'm doing it for this one, let me do it for the other ones as well. Okay, so this is this value here, so maybe r of mod d here, put a d like this, and for the last one as well, so I'll do like this, and %d colon value of that, and I need to put j for each one of them. So I'll put a j for this, and maybe j here as well. Let's try and run again. Yeah, that's exactly what we were looking for. Maybe 2 slashes for need. I don't know. We keep it like this. Yeah, at least we can read it. Okay, so yeah, this is what we have. So for each process now we know how much is the allocation, how much is the maximum required, and what is required for it to complete, how many are remaining for it to complete, right? So we know from this, at least we have an output now. So what we want to display next is, let's see this, what we want to display is, so we are done with this part, what we want to display is the sequence. So yeah, this is the real thing. So this is the banker's algorithm. We have not even started the banker's algorithm. These are just decorations. We are just trying to show what processes look like. So now what we are going to do is we are writing the banker's algorithm. So banker's algorithm is going to start from here. Banker's algorithm is going to start from here. So what we have to do for banker's algorithm is we have to go through each resource, we have to go through each processes, each resource, each instance, and then compare it with this value, right? If that resource is available or not. If it's not available, then go to the next one. If it's available, then check the other resource. Yeah, so we have to check that one by one. So we are going to have multiple for loops inside. So let's get started without wasting any time. So I'm gonna use int for processes, since we have been using I for processes. So I'll do this, and I is less than number of processes. So for each process, each resource, each instance, this is what we are going to work on, and I'm going to do I++. So this is my process. Inside my process, I want to see what I want to see. I want to see if the process has, okay, so what we are going to do over here is we need to see if the process has completed or not. So first of all, we need to have a check over here that for process 0, has it already been completed or not? If it's already completed, then no need to run through it again, right? This will further optimize our code. So for each process, then we need to have another variable that tells us if this process has been completed or not, right? So we have to declare over here maybe int complete, just a variable which is going to tell us if this process has been completed or not, right? Or maybe let's call it completed, right? Okay, so I'm gonna do something like this. So I'll put 0 for each one of them because none of them has been completed yet. We need to have a flag, right? If a process is complete, we need not run that again, right? It will save us a lot of time by going through each one of them and then getting to know that this process was already completed. So we don't want that, right? So I'm gonna put zeros for all of them, that none of the process has completed yet. And over here inside this loop, I'm gonna check that process has been completed or not. If that process is completed, then we'll see what we have to do. Okay, so if that process, which is proc of I dot completed completed is equal to false, or I mean 0, it has not completed, then we have to do something. If it has completed, then we do something else, right? We go to the next process automatically. If it has not completed, then what we have to do is we have to check for each resources, each instance for that process. So we are going to run another loop for int j is equal to 0, j is less than number underscore of, what happened to this? Okay, let me do it again. J is less than number of resources and j plus plus. Okay, so we have to run through each resource and we have to check if certain instance of a resource is available or not. So what we have to do is we have to check how many resources for R0, R1 and R2 process 0 requires. Since we are running I is equal to 0, since we are running through the first process, so we have to check how many resources, how many instances for each resource process 0 needs. If the availability of those resources are less than the need, then we need to break, because we have to go to another process, right? So this is what we are going to do. So if the need of the process, if process I dot need, and need is going, since need is an array, need of j, which means that since we are talking about process 0, so process 0 and resource 0, and basically for resource 0, so we are talking about this array now, this is the need array, right? So if process 0's need of resource 0 is greater than what is available for resource 0, is greater than the availability, what was the name of the array? Available, if available of j, so which is 3. So if 7 is greater than 3, then we break this. We break this process and move to the next process, because this process obviously cannot end. So why to waste time, right? We move to the next process because the availability is less than the need of this process, right? So what we are going to do is we are going to break over here. What break will do is it will break this loop and it will break this it will break this loop first, because we have to check for the next resource also, for next resource also, since we have 3 resources, and then it will go to next process also, right? So this is what we're gonna do, and it's gonna break. So if it's gonna break, then it's good, it's gonna go for the next process. But after breaking this, we need to tell our program that this has been broken here, and once the process has available resources for each instance of that resource, we need to put that in our array of sequence, right? We need to put that in the array of sequence, and that's what we are going to do. So if this is for the error, for unavailability, but if it is available, then what we gonna do, what we have to do over here is, so if the process is so we are basically here, if the process is not completed, then check for all the resources. If resources are not available, break over there. But if the resources are available, which means that this for loop will complete its execution, and it will check all the resources. This is basically for checking the resources, available resources and the need of the resource. If this is fine, then what we have to do over here is we have to just do we need to just add that process into this sequence. So process of we need to have an index for this one, because we cannot use I, we cannot use j, because I will increase with the number of increase in the processes, j will increase with the increase in the number of resources. So we need to have another, maybe somewhere outside, let's put it maybe an integer and an index for only this specific array. So we need to have an index for this, so that I can just increment that index for this array that is not being disturbed by I and j. So this is what I'm going to do. So index of sequence of index is going to be my process. What is my process? P of 0 in this case. I'm just saying, giving you an example, P of I. So that P of 0 or P of 1 or P of I will be stored in sequence, this one, right? So I know that which process it is, and I'm going to increment that to make space for the next one, right? This is what I'm going to do. So if that process is added into this array, then I just increment index so that the next process will come and save in that index. So this is this. One important thing over here to do is, if the process is being added to this, we have to release all of it, which means that when if I've added the process into this sequence array, which means that that process has completed, right? That process has completed. So that process has completed means I have to make that flag of process complete equal to 1, right? So let's do that. Process of, I hope you guys understand. So what is happening over here is, if I'm adding that process into this sequence, means that this process has been executed because all of its resources were available, and all of those instances of those resources were available, and they were more than the need of this process. So that's why we are just putting that over here, and we are incrementing that, and we are making sure that we tell our program it will only enter this if statement only if it is not complete. If it's complete, it will not enter. So if this process has completed now, whatever this process is, if it is completed now, we just make its flag completed is equal to 1, so that we don't run this process again. So that's exactly why we had this, right? Now we have incremented this process, whichever this process is, it will not run again, right? But at the same time, what we want to do is, the resources being used by this process, we need to release them, right? We need to release them. But before we release the resources, we have never allocated the resources. We have never given those resources to this process. We have just checked if the resources are available or not, right? We have never given those resources to this process. We have never given this. So we have to, and given means allocation, right? So we have to increase the allocation of the process and decrease maybe the available resources. Well, available resources shouldn't be a problem, because we are going to allocate and we are going to get that from the available. So what we have to do now is, we have to allocate those resources. You can do it before that, after that, it's absolutely fine. So what I'm doing over here is, I'm going to allocate the resources to this process now. Okay, so maybe int, I don't know, x is equal to 0, x is less than 3, and x plus plus is the number of resources, right? So you can put number. I'm just doing it both ways for you so that you guys can understand how to do it. So I'm just putting 3 over here, and what I want to do is, I want to give the resources from the available array for that particular resource to the allocation of the process, right? So if, for example, R0 was the availability of R0 is greater than the requirement of process 0, then I will allocate that resource to process 0, right? And that's it. This is what I have to do with, and I have to increment the availability, right? I have to increment the availability of that particular process. This is what I have to do. So this is what I'm doing over here. So my available will be, my available of x is going to be, for that particular process, is going to be like this. So proc of I of allocation of x. Let me see once again, available of x. Yeah, so this is what I am doing. For each process, the allocation is being provided from that available and incrementing that available, right? Because next time this loop runs, this available will keep on. So right now that process available of x, which is available of x, whatever the x is, it starts from 0 right now. So whatever is available over there, it will take the value from there and add the values to over here. Next time this available will go over here in this loop, it will be checked against the demand again. If it's less than, then it will break. If it's greater than, it will come to the process, come to the this for loop and increment this. So we have this now. The only problem right now, I believe, is let's run this code and see. It's not going to display anything. I'm going to display the sequence. Let's run the sequence. So we are not done with the code yet, but let me at least show something as the output so that we can see what's going on, right? So I'm gonna say printf, the sequence is the safe sequence is, and whatever is in my sequence, whatever I have stored, assuming that all the processes are done and everything is saved in the sequence, I'm just gonna run through the sequence, which I can do using a for loop. I'm gonna use I is equal to 0, I is less than since there are going to be certain number of processes, which is this one, n minus 1 from that. Let me use processes and I plus plus. You can do 5 as well. You can do it that way as well if you want. And I'm gonna print that printf, and let me display something. So p of maybe whatever the number of, so p0, p1 and p2, we want to do something like this. So p of I, which is like this, I'm gonna do, and it's just gonna display me. Let me put some space here as well, or let me put an arrow just like what we had over there. This will be much easier for us to understand. A new line is not required, and I'm gonna do sequence of I. So this is what I'm gonna do, and let's see what we have. That's pretty much it. Okay, this is this. So the safe sequence is p0, p1, p2, p3, p4. It's right now it's not doing anything because we still have to fix our code. Right now it's just displaying everything. It's just displaying starting from p0 to p4. It's saying that this is a safe sequence, but if we run through this, I'm not too sure if it's going to work or not, but I do believe that there is one loop more required, and there is an if statement required, which we need to fix because right now it's not respecting the resources. Or what we're going to do is, let's see if it works or not. So it's saying that, oops, where does it go? Let me run again. Okay, so it's saying that p0, p1, p2, p3. So let's see. So it's saying that p0 will run first. So p0 is, it requires so it has this one, it requires 7, and it requires 7, right, to complete the execution. But r0 is 3, it needs 7. So it's definitely not p0, it cannot run first. And it's r1, r1 is 3, so we can not run r1 as well because obviously it's less. And to obviously this p0 can't be here because you can see that it cannot run. It requires 7 of them, and we have only 3 of r0, so it's definitely not the first one, and this is the wrong sequence for sure. So what we want to do over here is, I know that this thing is working fine for displaying the number of processes, but what we have to do is, and why this is happening is, if we are inside this if statement, this thing is always running. This thing is always running. So we don't want that. This should only run when we know that this has been broken, right? This has been broken. So this is broken, only then this should run, right? Because if this will keep on running and we keep on breaking this, then this code will run after this. But we want a condition, specific condition to run this, and that specific condition is whenever this break happens, only then this code should run, right? This is exactly what we are looking for, right? So what I'm gonna do is, I'm gonna add another flag over here. So I'm gonna run a flag over here, and what this flag is gonna help me in, it's gonna tell me if the need is greater than available or not, right? So if it is greater than the available, then this code should not work, right? This code should not work. Right now what is happening is, if okay, let's run for p0. So we are here, right? So my need is 7, right, for the first resource, right? My need is 7 and I have only 3 available, right? I have only 3 available. Let's see how this code works over here. So what is going on over here is, so p of 0, need of j, which is 7. 7 is greater than 3, yes, it breaks, and then it runs this code as well, right? It runs this code. What it does is it adds that p0 into this sequence, but it should not add this into p0 in this sequence, because the demand for p0 is not fulfilled over here. So this code should not work. This code should only work if this condition is not true, right? If this condition is true, it will break this, but then it's still working, right? It's still working. We don't want that. We don't want that. So what we want to do now is, that's why what I have done over here is, this is one of the approaches. Obviously there are many other approaches. You can use another approach you like. So I'm going to use a flag which is going to tell me for each process the instance of each resource, if it is available or not, it is less than the need or not, right? So what I'm going to do is I'm going to add another flag. So let me add another flag over here, and I'm gonna make them 0. Initially they are all 0, right? Initially they are all 0, and we are just going to calculate that, and based on that this flag will be updated. So initially we assume that all the resources are available for our processes. This is how operating system starts, right? It assumes that everybody has a fair chance of getting the resources. But what I'm going to do over here is, I'm going to make sure that as soon as this if statement runs, I make my, no, this is fine. So yeah, inside this, so we don't want to run this code unless and until our flag is indicating us something. So when the demand of the process is less, I mean this condition is not, I mean if this condition is true, obviously that process should not run, right? Because the need is greater than availability. So I'm going to put a 1 over here, and whenever I'm going to have a flag for this process, I will make sure that I will not enter this code. So I'm going to put an if statement over here, very simple if statement, and I will check process of I dot flag is equal to 0. If it's equal to 0, only then run this code, right? If it's equal to 1, which means that demand is more than the availability, so we should not run that code. So if I do this, I'll just put all this code in this block. So just to indent that better way, so I do this. So this code will now run only if my demand is less than the availability or equal to the availability, right? So we have fixed this now. Let's try and run this code to see what we have now. Okay, so P1, P3, P4, P0, and it's displaying P1 again. Why it should not do that? It should not do that, and it's not displaying P2. Okay, let's see what's going on. So if we have P0 over here, P0 is not computed, obviously it will come inside. P0's demand is 7, that is, so this should not work, this should not work. For P1, it will go like this. So for P1, let's see, for P1 we have 200 and 122. So availability is 332, so this should work. So P1 should work. It comes over here, it will give it a flag of 1. It will not, so this will not run. Okay, right. So what is happening is, once we make flag 1, okay, so what is the output? Yeah, that is correct. So once we make flag is equal to 1, we are never making it back to 0. So every time I run this, the flag should be 0, although it is 0, but for that process, if it becomes 1 for one of the resources, then it should work for all of the resources. So yes, before I run this, I need to make it equal to 0. I should make this equal to 0 as well. And although it will be 0, let's try this. so I have to make it 0 every time. I have to make it 0 every time, and this is fine. Let's run this code now and see what's going on. P1, P3, P4, P0 and P1. It should not be P1, it should be P2. So maybe something wrong here. Okay, so what's going on is it's displaying me P1 once again. It's running out of this. Okay, let me do something like this. Okay, if I do this, it will run from 0 to 4, and let me display this outside. What will happen now? Let's see. So sequence of let me say number of processes here, and see what's happening over here, and -1. Let's see now, because of maybe running outside that array. P1, P3, P4, P0 and P1. It should be P2. Okay, let's see. No problem, we can fix it. Okay, so it's running for the process. So first time it runs, it will run for all the resources, and it will break here. It will go to flag and see and run this code. It will do this, do the completed, and it's not running for, yeah, it's running for the processes. It's running for each of these processes, but it's not running back. So yeah, so what we have to do is we have to have another array here, another loop here that should run it back from beginning, because it's not running it back. So if I do this, I think I found the error, the logical error. If I run this, let me just paste everything inside this. I have to run it once again for all of them, then it should be able to work. I think so. Let's see. Okay, let's see now. Yep, it's working now. It's working now. So it's P1, P3, P4, P0, P2. It should not have this. We can fix this. That's just a yeah, that shouldn't be a problem. We can fix this. That's not a problem. But at least, I mean, it's showing us all the numbers over there, all the processes over there, and I think it's working fine. We can figure that out, hopefully. So first one is P1. We know this because all of the availability of the processors. So P1 is P1, yeah, so it's this one, and we have availability, we have this one availability, this one availability. So for this we have the availability for all of them. That's fine. So after we are done with this, we have enough resources. And then P2, so P2, for P2 we will get the availability of so 3 and 3, 6 and 5 and 4. 6, 5 and 4 will be available after P1. So we know it's 6, 5, 4. So P3 will run, P2 will run. So it's saying P3. P2 can also run, but it's running P3 maybe. So 0, 1, 1. I think it should be fine. I'll try and dry run after this, because I don't want to make this video very long. It's already quite long. So I think this is the code, and I'm gonna stop over here, and I will check by dry running it. I will debug this to see if it's displaying it properly or not. So if there is a mistake in this, we'll come back and fix it. But let me pause my video here, and I am going to debug this, do it on paper to see if this is running properly or not, and I will resume the video after that. Hi guys, welcome back. I have just debugged the code, and it seems that it's working absolutely fine, at least for the data I have over here. I have tried to run it through different cases, at least 2 of them, and it was working absolutely fine for me. So you can try to change this data and see if the code is working or not, but I've seen the code as well once again, and it is making sense to me, so I guess it's pretty good. So try to do it yourself. As I said earlier, there are a lot of solutions available for this banker's algorithm online. You can try some other code as well and see the output of that program, and you can compare it with the output of this code as well. You can write your own stuff as well. So you know how banker algorithms works now. I have explained that to you and why we are using banker algorithm. We are trying to see the safe state. So if you want, you can write your own algorithm, try to do that and see if it works or not. So I think that's pretty much it for the lab exercise. I will stop this lab exercise over here as it's giving us good results. I think it's working absolutely fine, at least on the data I checked. So it's working fine for me. What I'm gonna do now is, as I said during the theoretical part as well, this week we are going to have another assignment. So this is the assignment for you guys. So it's assignment number 2. It's for 10 marks, and you have 3 weeks for this assignment. I've given you plenty of time for this assignment, and this is not a programming assignment, so I don't want you guys to do coding only in this course. It's not only a coding course, that's why we are having blend of coding and theoretical part as well. So this exercise, this assignment is going to be a report, so you will not be coding in this. So let me quickly explain this assignment to you. It's pretty simple. So there is a problem in operating system which is called a dining philosopher's problem. It's a very famous problem in operating systems, and you just have to study about this problem, what this problem is, and there are several solutions to this problem available in existing literature as well, and you have to write a report on this problem, and that report has to be 1500 words minimum. You can write more than 1500 words, I don't mind, but don't write anything less than 1500 words. All right, so in this assignment what you have to do is, since you are writing a report on this problem, you have to make sure that you write in such a way, since there are many solutions to this problem, you pick one of those solutions and you compare that solution with other solutions, existing solutions in the literature, and you have to tell why the solution you picked is better than the other solutions. So you pick one of those solutions, analyze that solution, see why that solution is better than the others. You have to give a solid justification of why you have picked this solution and why you think this is the best solution available in existing literature. So you have to provide that analysis, and then make sure you also write the pseudocode for this, and there are a lot of pseudocodes available on the internet, and obviously you are going to pick from one of these solutions, one of the many solutions available for this problem. So you can pick the pseudocode of that solution as well and include that in this report as well, and you have to tell why this solution is better, as I said earlier, and you have to compare that, maybe because the efficiency is better. I don't want to give you some aspects of this algorithm. I want you guys to research this or learn this from beginning. I don't want to tell what this is, and I want you guys to see what this is and learn, because I want to see your research skills as well. This topic, this operating system course is a high level course, and it requires you to have at least some level of research, some level of understanding, some level of self-study in this course as well. So this is that part of the course where you have to go to the internet, go to the books, see what this problem is all about. You're free to see YouTube videos, and I would highly recommend to do that. There are quite excellent videos out there. You have a look at those videos and see different solutions available. Pick one solution, see why it's better, analyze that solution, compare it with other solutions as well, and make sure you provide a good justification of why you have picked that solution. Also, it's very important to give examples, why this solution is going to be better, in which cases it's going to be better, in which cases it might not perform well. So you have to discuss all of those things. And a good assignment would also contain a diagram of dining philosopher's problem, and it should also contain the application of this dining philosopher problems in operating systems. So okay, we know what a dining philosopher problem is, where do we actually use them in operating system, what problem of operating system does this solution solve. So you need to include that in your report as well. So that's pretty much it. I mean, it's pretty straightforward. You have to write something on one of the topics, minimum 1500 words. It's not too much. I think it's 2 pages maybe. It depends upon your font obviously, but it's not too much. I just wanted to give you something where you can go to internet, search from there, and learn something from there as well, instead of just going through the lectures and learning all the concepts from there. So please do that. These are the instructions. So you have, don't forget to write your name and ID. I've said this many times, I'm saying this again and again, and I still see 1 or 2 students are missing their either name or ID. Please don't miss your name and ID. Submit this by writing everything inside this Word document. So do not create a separate document. Make sure you write everything at the end of this document over here. So start writing your report here and submit. Make sure your report has at least these headings. So you should start with the introduction of the problem. Then you should have another heading, analysis. In this heading you will do an analysis and comparison of different solutions, and you pick one of them, add a pseudocode, add a diagram over here. Maybe you can add a diagram of philosopher's problem in the introduction as well. And finally, in the conclusion section, you can conclude your arguments, and then references. Obviously this would require you to refer some documents, some links online, so please do include the references part in references heading or section in your report as well, and make sure your references are in APA style. I'm sure you have been writing different reports, and this will give you a very good understanding of what APA styles are, because in your final capstone project you are going to work on all these things. So it's a good idea to get some practice through these courses, and these courses actually do want you to do these things. So please make sure you include at least these headings. You can include more headings if you want, I don't mind, but missing these headings might affect your marks, so don't miss any of these headings please. So do that, and it's 10% of your total course. So this assignment contains 10% of your total marks, so make sure you do it good, like what you did in the previous assignment. It was really good, so make sure you do something like that, or maybe better than that. And obviously this is not a group assignment, it's a per student assignment, so any 2 assignments that are similar are going to get 0. And obviously this is a report, so it will be run through a Turnitin. So I will get the percentages of plagiarism, so make sure you don't take content from online, from anywhere. As I said, that you have to explain this in your own words, so you cannot copy paste the content from the internet. Diagrams, figures, pseudocodes, yes, you can take that from the internet, but then you have to provide the reference for that. But words you cannot copy, that. All right, please do not do that. You have 3 weeks for it. Deadline is November 13th, so you have around 3 weeks, so you have good amount of time to complete this assignment and submit through Blackboard please. And while you are submitting this assignment, make sure you are uploading the right file. Some students upload the wrong file and then they approach me through email saying that I have uploaded the wrong file. I mean, we know which is the right file. Please look at your file before you actually submit it. So make sure you submit the right file and submit that before this deadline. And obviously it is going to run through Turnitin, so just be careful. Like always, this is a rubric I'm going to use to mark your assignments, and that's pretty much it. Please put your solutions over here, so your report should start from here. You can remove this solution if you want, no problem. Start your report from here, and do not miss to write your name and ID over here. So your ID, your name over here. And that's pretty much it for the assignment. You will find this assignment on Blackboard on coming Wednesday, and after that you will have 3 weeks to complete this assignment. If you have any problem, if you have any questions, anything that is bothering you, anything you think I can help you out with this in this course, in this assignment, please reach to me and we can work on that. As always, if you have any other problems maybe not related to this course and you think I can help you out with that, you can always reach and we can discuss, no worries. And that's pretty much it. I'll be uploading all these PDFs online as always. Find them under the respective folder, And yeah, that's pretty much it. We had deadlocks today. It was pretty interesting topic, very very important as far as your final exams are concerned. So go through them. If you have any questions, please meet me in my virtual office hours, and again, if they don't suit you, we can fix and find another time for that. So that's it for this week. Have a nice day, have a nice week ahead. Wish you all the very best for your assignment. Good luck. Bye bye.